Okay, ladies, welcome to our first flipped classroom, and today we are talking about tree diagrams. The great thing about a tree diagram is it's a really nifty visualization technique to kind of look at the probabilities. So it displays a sample space along with the probabilities. So we're going to look at a simple one first. This is our favorite table, the one we've been using so often, that deals with grade level and whether or not students voted for uniforms. Okay, ladies, so let's go ahead and start with our tree diagram. So we have students in our study. So these are all the students in our study, and we're going to basically branch out, hence the tree, the different categorical variables. So there's two categorical variables, really. There was the grade level, and then whether or not how they voted on uniforms. I'm going to start by grade level because it just works for me. So there's two possible grade levels, junior or senior. You could have done it with instead how they voted on uniforms, but I just chose this way. So if you're a junior, you had two possibilities. You could have voted yes for uniforms, or you could have voted no for uniforms. If you're a senior, you could have voted yes for uniforms or no for uniforms. So here's all the different possibilities that we have. Okay, so let's look at the probabilities and how we would lay them out on our branches. So this branch right here is going to be all of our juniors. So of our juniors, if we look back at our chart, there's 156 juniors out of 315 students total. And if I do the math, that probability is 0.495. Okay, then going to my seniors down here, there are 159 seniors out of 315 seniors, so that probability is 0.505 that a student is either a junior or a senior. But we can get even more specific than that. We can be like, what's the probability of a junior who said yes? So 62 of our juniors said yes, so we're going to write 62. And of our juniors who said yes, there were only 156 juniors. Okay, so that probability is 0.397, and you can write it as a fraction here or as the decimal, whatever you kind of want. I don't know if you noticed, but ooh, look, that's the probability of saying yes given that you were a junior. Ooh, conditional probability. Okay, so now we go down here and we say, okay, what's the probability of someone saying no given that they're a junior? 94 out of 156, and that total we have is 0.602. Again, it's the same thing up here. You don't need to write this. This is just because you're awesome and I wanted to show it to you. That's what we have there. Okay, same deal here. On this branch, I would put this probability. 57 of our seniors said yes, and that's out of a total of 159 seniors. So that probability is 0.358. And then on this branch, we would say, okay, 102, because that's the seniors who said no, and that's out of 159 for a probability of 0.641, or something similar to that. Again, these are conditional probabilities, right? Woohoo! Yes, given that they're a senior, and the probability of no, given that they're a senior. Okay, so the beauty part about all of this is here I have all of my probabilities. This branch, I have this branch here for my juniors, and I have this branch here for my yes of given that they are juniors. So what if I just want to find this probability? What's the probability of someone being a junior and yes? Okay, a junior and yes. So how would I do that? Well, basically, I'm going to take this branch and multiply it by this branch. So if I were to do that, and I'm just going to show you one of these here, I would say, okay, it's 156 divided by 315 times 62 divided by 156. Ooh, look, they cancel out. So it ends up being 62 divided by 315. When you do that, that's your total right there. Okay, so this ends up being 0.196, and that's your juniors. Okay, and yes. So when you multiply the branches, you get those same things. Okay? If I were to multiply juniors and no, it would be this number times this number. Okay, if I wanted seniors and yes, it would be this times this. If I wanted seniors times no, it would be this times this. So you can see where all the probabilities are coming from, and you can see how a tree diagram is a super helpful way to sort of look at probabilities and calculate probabilities. Okay, ladies, so taking a look at the problem we just did, essentially we were asking, can we find the probability of a junior who voted yes? With the tree diagram, we just multiplied the two branches together, but we can also do it with notation. The probability of someone being a junior is just 156 over 315, and the probability of someone who voted yes, given that they are a junior, is 62 over 156. The 156 cancel out, just like we did before. Hey, it's the same exact problem. And we end up with 0.196 probability. So what we have now leads us to what's called the general multiplication rule. Okay, so the general multiplication rule is this right here, that the probability of A and B is equal to the probability of A times the probability of B given A. Now on your fancy-dancy formula sheet, you're going to see it written slightly differently. You're going to see it written as the probability of B given A is equal to the probability of A and B divided by the probability of A. So this is what's given to you on the stats exam, which is slightly different from this formula. It's the same thing, it's just algebra. We love algebra. Okay, this particular one, we use this when we need to find A and B. Okay, so to figure out the probability of two events occurring together, we really need to know that the probability that the first occurs times the probability that the second occurred, given that the first already happened. Now this creates a lot of problems and story problems, because they give you a bunch of numbers and they'll be like, oh, I have 0.24 and that's the probability of B or A or something, and they don't necessarily tell you what it is, so you're going to have to, as soon as you get a number, you're going to have to be like, what is that the probability of? Is that the probability of A? Is it the probability of B? Is it the probability of B given A? What is that probability? So that's going to be the hard problem with the story problems, is actually figuring out what the probability is. Okay, example time. Media usage and good grades. In January 2010, the Kaiser Family Foundation released a study about the influences of media in the lives of young people aged 8 to 18. In the study, 17% of the youth were classified as light media users. I'm going to stop right there. When I do a story problem like this, I stop as soon as I get a number. So it said in the study, 17% of youth were classified as light media users. So I might be like, okay, the probability of light media users equals 0.17. Then I would keep reading. 62% were classified as moderate media users. So mod was 0.62. You can actually see that. Okay, and 21% were classified as heavy media users. Heavy. Okay, 0.21. Of the light users who responded, 47% described their grade as good, like A's and B's. Okay, so we have, of the light users who responded, we have the grades that were good. So this is a conditional probability. So this is the probability that someone is good, has good grades, given that they are light users, right? 0.74. Okay, so that's right there. And then we go on to, while 68% of the moderate users and 52% of the heavy users describes their grade as good. So then we have the probability of good given that they were moderate, 0.68. The probability of good given that they were heavy users, and that was 0.52. So I tend to write these as I go. The most confusing part for me is figuring out what the problem is actually trying to tell me. So then it says, according to the study, what percentage of people aged 8 to 18 describe their grades as good? This looks like a big problem, and a big problem calls for a 4-step plan. That's right, state, plan, do, conclude. So that's what we're going to do. Okay, so state. We literally just state the problem. I would say, what percentage of young people say they get good grades? Hey, it's that simple. Okay, so now we're on the plan part. So we're going to just list what we have. What do we know? That's the great part about plan. So what do we know? We know the probability of light users is 0.17. The probability of moderate users is 0.62. The probability of heavy users, 0.21. The probability of getting good grades given that you're a light user, 0.74. The probability of good grades given that you're a moderate user, 0.68. And the probability of good grades given that you're a heavy user, 0.52. My goodness, that's a lot of probabilities. To me, it looks like we should make a tree diagram. So that's what we're going to do. Okay, ladies, so now we're going to do our tree diagram, which is going to be part of our plan in this. And our plan is really setting up so that we can figure out what kind of mathematical calculations we're due. So a tree diagram is actually a plan. So I'm going to start by taking the categorical variable of the type of user. So I have light, moderate, and heavy. And the probability of light, moderate, and heavy were all given to me. And I listed them on the previous slide. So probability of light was 0.17. Probability of being a heavy user was 0.62, or moderate user, excuse me. Probability of being a heavy user was 0.21. Okay, so now I have those. Then I have to add in my other categorical variable, whether their grades were good or let's just say not good. So we had good, not good, good, not good, good, not good. Okay, so we were actually only given the probability of their good grades. So we were given good grades, or good grades given that they had a light, they were light users. So that's 0.74. But how could I figure this one out? Just in case I wanted to know it. Why, it should equal 100, right? So 1 minus 0.74 should be 0.26. Okay, then good grades given that they were a moderate user was 0.68. And I can do the same thing for not so good grades, right? 0.32, I think, with the 7 and yes, okay, there you go. Math, it's awesome. Okay, 0.52 is good grades, and then 0.48 would be not so good grades. So there's my tree diagram. It looks beautiful. So then I need to figure out what I'm going to do from here. So what am I going to do from here? I need to look back at my question. My question is essentially, I want to find the unconditional probability of getting good grades. So I've got good grades in 3 places, 1, 2, and 3. But these are good grades given that they're a light user, good grades given that they're a moderate user, and good grades given that they're a heavy user. So if I want to find the probability of good grades and light, the probability of good grades and moderate, and the probability of good grades and heavy users, then I will actually, when I add all these up, I'll get the probability of everyone with good grades, right? Because these are people who had good grades but were also light users, good grades and also moderate users, good grades and heavy users. So when I add these 3 numbers together, I should end up with all of the people that had good grades. So how do I get this probability of good grades and light users? Well, I multiply my branches, right? So 0.17 times 0.74 should give me my probabilities. Now I'm showing you that on this, but I would actually put the math section of this into the do. So that's what we're going to do. Okay, so for the do, I would say there were 3 groups of students who had good grades. And I might actually write this down. There are 3 groups of students who had good grades. Those with light users, those with moderate users, and those with heavy users. So we're going to add all the probabilities of being in each group together. So the probability of getting good grades is going to be the probability, and I'm just writing this in notation so it's easier, probability of light and good grades and light, probability of good grades and moderate use, plus the probability of good grades and heavy users. So to find these, I go back to this original problem. So the good grades is 0.17 times 0.74 plus the probability of good grades times, so let's say this is 62 times 0.68 plus 0.21 times 0.52. Again, all I'm doing is multiplying my branches. I'm saying what is the probability of a light user and then good grades given a light user, and that should give me good grades and light users. So when I total all this up, let's see, I get 0.2, just kidding, 1258 plus 0.4216 plus 0, that's a plus, 0.92. So that equals my total probability of 0.6566. Woohoo! Okay, now here comes the conclude part. I came up with my probability in the last problem, right? And we had a big talk about context. I can't just say, hey, here's my answer, boom. What I need to say is about, I don't know, 65.7% of the students in the study described their grades as good. Bingo. There we go. In context. It's beautiful. We love it. Context is best. Okay, and that is how we build the tree diagrams and how we use tree diagrams.